Welcome to today's lesson where we will evaluate an integral using the substitution method. We'll evaluate the integral of x cubed times the square root of x squared minus 1 dx. To deal with this integral, we'll start by identifying a proper substitution that can simplify the expression. For this problem, a good substitution choice would be u equals x squared minus 1. Why? Because this makes our integral in terms of u easier to handle, especially the square root term. Let's explore how this choice helps. First, let's find the differential due. Taking the derivative, we get due equals 2x dx. Solving for dx gives us dx equals due over 2x. Now, we substitute u and dx back into the original integral. The integral of x cubed square root of x squared minus 1 becomes substituting x squared minus 1 as u, so we have x cubed times the square root of u times dx, which is due over 2x. By simplifying, we see that x squared times the square root of u times due over 2. This results when we take out one factor of x in the fraction. So we are integrating a simpler expression x cubed times the square root of u times dx equals 1/2 times the integral of x squared square root of u times due. But we still have x squared in the integrand. Let's return to our substitution. From u equals x squared minus 1, solve for x squared to get x squared equals u plus 1. Substitute x squared equals u plus 1 back into the integral. This gives us 1/2 times the integral of parentheses u plus 1 parentheses times square root of u due. Now let's expand the expression inside the integral sign, u to the power of 3/2 plus u to the power of 1/2. Let's integrate these terms one by one. For u to the power of 3/2, we add 1 to the exponent and divide by the new exponent, which gives 2 over 5 times u to the power of 5 over 2. Similarly, for u to the power of 1/2, adding 1 to the exponent, we get 2 over 3 times u to the power of 3/2. Now substitute these integrated results back into our expression. Remember the 1/2 factor outside the integral. We'll get 1/2 times the quantity 2 over 5u to the power of 5 over 2 plus 2 over 3u to the power of 3/2 plus a constant of integration. And we're almost done. Let's go back to x, substituting u back to x forms. Recall that u equals x squared minus 1. Let's plug that back into the antiderivative. The final simplified expression is given by 1/10 times parentheses x squared minus 1 to the power of 5/2 plus 1/3, parentheses x squared minus 1 to the power of 3/2 plus c. Thus, we have evaluated the integral using substitution.